Hello everyone, welcome to Z&Z Classroom. In this video, we'll be learning about X and Y intercepts. So the concept of this is very easy. For X-intercepts, you're finding where the function intersect with the x-axis. And for Y-intercept, you're finding where the function intersect with y-axis. So since the concept is easy, we'll be discussing more about the different problem types of this concept, and we will start with equations. So first, let's start with equations. So when the problem gives you an equation and lets you find the x or y intercepts, without you graphing it, how would you find them? So first of all, for x-intercepts, you're basically set y equal to 0. Okay, so basically you're setting y to 0. And for y-intercept, you're setting x to 0. Okay, I'm gonna both use this y. So right here, something to notice here is that I put s here in parentheses for x-intercept because for equations, for different functions, you could have multiple x-intercepts, but you could only have one y-intercept because of the definition of functions that each x value, you could only have one output value. So you could only have one y-intercept, okay? So I'm gonna just put functions in parentheses, I guess. It's technically similar. Okay, so let's try an example with linear functions first. So example 1. For example, let's say I have a linear function of y equal to 5x plus 6. Okay, so how can I find the x-intercept of this? For x-intercept, you're setting y equal to 0 and solve for x. So setting 0 equal to 5x plus 6. And then you're subtracting 6 on both sides. So negative 6 equal to 5x. And then divided by 5 on both sides. And then I would just flip 2x to the left side. So x equal to negative 6 over 5. And something to notice here is that for x and y intercepts, you have to put them in coordinate form. So it's negative 6 over 5 comma 0. Don't just put x equal negative 6 over 5. That seems like a line or something. So don't put in coordinate form. Okay, that's for x-intercept. So for y-intercept, you are setting x to 0. So what you would do here is that so y equal to 5 times 0 plus 6. So y is just equal to 6. And remember, put in coordinate form. So it's 0, comma 6. So many people already know that for y-intercept in linear functions, it's just this value right here. So like I have y equal ax plus b. This b right here is my y-intercept. So just want to mention here. Okay, so that's for linear function. It's really easy. Linear function only has one x-intercept and one y-intercept. So let's go to quadratics. For quadratics, there are three different types. There's without x-intercept, y-intercept, and two x-intercepts. So I want to I'm not gonna talk here about the discriminant, but you guys will learn it later. The discriminant is a thing that you use to determine whether there's one x-intercept, 0 x-intercept, or 2 x-intercepts. Okay, so let me give you a really simple example. So let's just say, oh sorry, let's just say I have a function of y equal to x squared. right? So that's example 2. So y equal to x squared. That's a really the basic quadratic function, right? So how would you find your x and y intercept? So for this one, when I plug in, when trying to find my x-intercept, I will plug in y. I will set y as 0. So 0 equal to x squared. So x equal to 0, right? So my x-intercept is 0, comma 0. And for my, so there's only one x-intercept because there's not like positive, negative, 0. It's just 0, right? And then for y-intercept, you're gonna do y equal to 0 squared, so y equal to 0. So it's also 0, comma 0. So let me just draw a quick graph to let you know that what the graph looks like. Basically looks like this. So I would just have just draw a random function here. So basically my x and y intercepts are the same and they all are here at 0, comma 0. Okay, that's y equal to x squared plus y equal to x squared. So let me give you another example. So let's see, how about y equal to x squared plus 4. So when I try, same thing, when I'm trying to find my x-intercept, I plug in y 0, so 0 equal x squared plus 4, and negative 4 equal to x squared. So from here, you could see that x squared equal to negative 4. So we couldn't have a number despite maybe imaginary later, but like right now for real numbers, you couldn't have a number being squared equal to negative 4. So there will be, for x-intercept, there will just be no x-intercepts, right? So there isn't any. But for y-intercept, there will be. So I will set it equal 0, y equal to 0 squared plus 4. So y equal to 4. So 0, comma 4 will be my y-intercept right here. So, okay, so that's example 3, right? And this graph here, this chart here, we're going to be use it later. Okay, so let me give you one more example on quadratics that will conclude quadratics here. So it's y equal to x squared minus 4. So it's when you're trying to find x-intercept, set y equals 0, so 0 equal to x squared minus 4, and then x squared equal to 4, and x equal to positive or negative 2. So in here, from this step to here, many people would say it's positive or negative 2 because both positive or negative 2, both positive and negative 2 squared, it's equal to 4. But here I want to introduce you with a more, I think it was a better way to explain this. So basically, this is kind of not about XY intercept, but like I want to introduce it here about how when you're solving like this type of thing. So for example, I'm going to write it here. So if I have 4 equal to x squared, right? First of all, I'm going to square root both sides. So technically, when I square something, then I square root it, it's basically the absolute value of it. So in here, I'm going to say its absolute value of x is equal to 2, right? When my absolute value of x is equal to 2, then my x originally would equal to positive or negative 2, because positive 2 absolute value of it is still 2, negative 2 absolute value of it is still 2, okay? So this is just an extra point I want to talk about, okay? So now I've got that my x-intercept are 2. So it's negative 2, 0, and 2, 0, okay? Or I'll say or 2, comma 0. And then for y-intercept, I will y is equal to 0 squared minus 4. Y is equal to negative 4. So 0, comma negative 4 is my answer. Okay, so that concludes the equations part. That how would you find the x and y-intercept without graphing it? So next we're gonna from the graphs. So the graphs is quite easy. Basically, you are trying to find where the function intersect with x or y axis. So graphs, right? So I'm just gonna give one example here. That's actually I'm gonna give three. So let me see. All right. So let's see. So example, I'm keeping for graphs example one. Okay. So for example, I'm still gonna start with linear functions. Okay. So here I'm gonna start with linear functions. For example, if I have maybe a line like that, right? What will be my x and y intercept? So I'm gonna label this 0, 1, 2, -1, -2, 1, 2, -1, -2, right? So my x-intercept here, oh, by the way, x-intercept is also called as 0. So when you see zeros, it's basically x-intercept. So x-intercept is right here, right? So when the function intersects with the x-axis is your x-intercept. So when I write it, it's -1, 0. And y-intercept here is right here, which is 0, 1. Okay, so that's easy. And next example, I'm gonna say a quadratic, right? So for quadratics, I'm still gonna draw a graph here, and still gonna label 1, 2, 1, 0, 1, 2, -1, -2, -1, -2. So for example, if I have one that was like that, right? So this is not a very good graph, but let's see. So I'm gonna still like that. I'll just, so it's a point here, a point here, and a point, I guess it should be on here. Let's just say that was -1, right? So my x-intercept here first is what? So my x-intercepts, here I have two, which are -1, 0 and 1, 0, which are this point right here and this point right here. And my y-intercept is right here now. So it's y-intercept, it just 0, -1, right? So, okay, so that's for my quadratic functions. So I'm gonna give you an example that maybe it's just a random function, and how would you see your x and y intercept? So here is a random. Draw this first. So 1, 2. Sorry, wait. This is a little bit off. So let me draw it one more time. So 0, 1, 2, -1, -2, -1, -2, and 1, 2, right? So let's see, I have a random function that was like maybe cross here, cross here, cross here, and like that right here, that was like this right here, okay? So, okay, so like that. When I have this function right here, when I try, it's basically the same thing, right? So when I'm trying to find where it crosses the y-axis, it's right here. And x-axis is 1, 2, 3 points right here. So my x-intercepts here. So x-intercepts, there are 3. So which are -2, 0, -1, 0, and 2, 0. So which are this one right here, this one right here, and this one right here. And then my y-intercept is right here, which is y-intercept, which is 0, 2. Okay, so that concludes our graph portion of this. And lastly, we're gonna do the chart part. Okay, so the chart part. Charts. Okay, so now I'm gonna use this right here to help me with this part. So this chart right here will be helpful. So my goal for this, we don't need to find where the y-intercept is. Our goal is to find where the x-intercepts are. So because I'm not gonna give you a chart of a linear function or a quadratic function that you could write out the function and then you find where the x, y-intercept are or is. But right now, I'm gonna give you a random, I don't even know what that function is. I still can find where, like a range of your where the x-intercepts would exist. Okay, so for example, if I have maybe x as -2, -1, 0, 1, 2, 3, 4. Then my here is it will be maybe y is -5, -4, 2, 5, 8, 10, 15. That's these two numbers are not good. Let's just say it was -3 and -2. So where are my x-intercepts? So basically from the graph, you want to find where your x-intercept is. You will find where the y goes from negative to positive or positive to negative. So in here, the y is in here from -4 to 2, it goes from negative to positive, right? So there has to be an x-intercept in here. And here from goes from positive to negative. Between here, it has to have an x-intercept between them. So why would that happen? So imagine that if I have, I'm gonna draw it randomly. Imagine that if you have something like this, right? When you have an x-intercept here, you need to go through that point. So it's easier you go from positive to negative, where you go from negative to positive. Okay, so if you want to further proof, let's draw this chart right here. Okay, so let's see. Probably need some more points here. Hopefully that's enough. I'm not sure. Let's see. So let me just use 0, 2, 4, 6, 8. And here I will use 1, 2, 3, 4, 5. Yeah, that's fine. 5, 6. Okay. So -1, -2, -3, -4, -5, -6, and then -2, -4, -6, -8. So let's prove that my theory that goes from positive to negative or negative to positive, and x-intercept will exist. So -2, 5, -5, so it's somewhere right here. And then -1, -4, it's right here. And then 0, 2, it's right here. 1, 5, it's right here. 2, 8 is here. 3, -3 is right here. And 4, -2, it's right here. So when I try to connect them, right? So let's just say that ends here. I don't really mind. So let's see. So I will have a point right here, that's the x-intercept, and a point right here, that's the x-intercept. So let's see if it's between the range -1, 0, and 2, 3, right? It's between -1, so it's between -1, 0, and 2, 3. So that proof is correct that when you go from negative to positive, so negative to positive for your y values, or positive to negative for your y values, between that range, between that x interval, you're gonna have a x-intercept. So my answer here would be -1, 0, and or 2, 3. Okay, so that will be a chart question right here. So I think that concludes our lesson today for x and y intercept, and hope you enjoy it, and feel free to comment below if you have any questions. Thank you for watching.